So in today's lesson, we're going to be talking about a very important process in mathematics, which is factoring. And I've already sort of given you the preamble about how important factoring is as a key skill when working in algebraic problems. So the first type of factoring we're going to learn about is the simplest of all the types, and that is common factoring. So you may be thinking, well, what the heck does it mean to factor something? So I'm going to try to work through this so that you understand what factoring is. So in math, we talked to you about a whole slew of processes that are opposite operations. So for example, if I were to say to you, blank is the opposite of adding, you know the answer to that. You know that that is subtracting. By the same token, blank is the opposite of multiplying. You learn multiplication, and then you learn division as the opposite process, right? So we know that division and multiplication are different sides of the same coin. And blank is the opposite of squaring. We would say that taking the square root. So I don't know if this is really a word, but I'm going to write it out. Square rooting. There we go. So when we say, well, what is factoring then? I would say in the same tone, factoring is the opposite of expanding. So let's take a closer look at that. So if I were to give you an example of an expansion, I would say, well, if I wanted to expand 2 bracket x plus 3 here, I would expand that by distributing that 2 inside the brackets. And that would give me, of course, 2x plus 6. Now, if I were factoring, what I would essentially be doing is undoing the expansion that I just did. So over here on the right-hand side, I'm going to factor, and what that really means is to undo the expansion. So how do I do that? Well, I take a close look at both of these factors. And this is the binomial. It's got 1, 2 terms separated by this addition. And so what I'm looking for when I'm common factoring is I'm looking to say, well, what does the 2x term and the 6 term have? What do those have in common? And I know that, so I look at for the numerical component, the 2 and the 6, and I would look for the variable component. So when I look at the numerical component, I know that in the number 2, there's a factor of 2. And I know in the number 6, there's a factor of 2 as well. So I can pull out a 2 as a common factor because both 2x and 6 can both be divided by 2. So if I wanted to on the side, I could say, okay, well, I know that 2x can be divided by 2, and I know that 6 can be divided by 2. Both of them can be divided by that same value. So then what I do is I write out, well, what are the leftovers once I pull out that factor of 2? Well, I know that once I pull out the factor of 2 over here, I'm simply left with x. And so that becomes the first term. And then in my expression, when I've pulled out that common factor. And then when I pull out the factor of 2 over here, out of my 6, well, I know that I'm left with 3, so that becomes positive 3 in my brackets. And if you look closely here, all I've done is I've just undone that expansion. And that essentially is what common factoring is. Factoring in general is undoing an expansion, but common factoring means pulling out a term that is common amongst the polynomials terms in your expression. One way that we could think about it is that by factoring, what we do is we take a sum or a difference, okay, so an addition or a subtraction, and that's what we see over here. This is a sum. And we're going to rewrite it as a product. Now, so sum or difference we know means adding, means adding or subtracting. But we're going to rewrite as a product, and product, of course, means multiply. So in this case, let's look at that. Well, we've taken this 2x plus 6, that is a sum right there, and we've taken it and made it into a product, 2 times x plus 3. So this is one way to think about it as well. So as I've already mentioned, common factoring is the simplest type of factoring, and it's the type of factoring that you're always going to want to do first. And it involves removing what we call the greatest common factor, which I've simplified to GCF. From all of your terms, they all have to have some common elements in common. Okay, so extremely important here, extremely important. We are going to learn about different types of factoring, but common factoring should always be attempted first, before any other type of factoring takes place. We're going to always look to remove any common factors. All right, so let's start with some examples. So this is example number 1. So 10x minus 15. Let's start off really simply with this. So I'm going to, write my equal sign. And what I'm looking for here is, I first examined the coefficients, right, the numbers, 10 and negative 15. And I can see here that the 10 and the negative 15 can both be divisible by 5. And that is the largest value that both of those coefficients can be divided by. So that tells me that I can pull out a common factor of 5. I'm going to do that. And then that means that what's left over is going to go in these brackets here. Right? And so on the side or in my brain, I can say, well, when I pull out, out of that 10x term, when I pull out the 5, I'm essentially dividing that 5 out. Well, 10 divided by 5 leaves me with 2, and I haven't removed an x. I haven't really talked about the x here. I'm going to go back. I really should have talked about that. Now, I know that, this first term has an x. The second term does not. So for that reason, I cannot pull out the x from this whole polynomial. I can only pull out the 5. And so when I go ahead and I pull out the 5, I divide out the 10x by 5, that leaves me with 2x. So that tells me what remains for that first term. And I can always go back and kind of check it, right, to see if I get what I started with. So 5 times 2x, I know gives me 10x. And so that tells me that I've pulled it out properly. Let's get rid of that. All right, so let's keep going then. So on the side or in my brain, I'm going to say, well, negative 15. And I pulled out this common factor of 5 here. And so I need to divide my negative 15 by 5. And that gives me negative 3. So that tells me that I'm going to say 2x minus 3 is what's going to remain in my brackets. And again, I can test that, right? So we already did the 5 times 2x will give me 10x. And then 5 times negative 3 will bring me back to negative 15. So I've removed the common factor. I have common factored this expression. All right, so I would like for you to test the waters a bit. I would like for you, even though we haven't seen a question like this, I would like for you to give it a whirl. And then when you're ready, start the video again. And we can take up the question. So maybe you'd like to use your whiteboard to give it a try and then write the permanent answer in your notes, whatever you would like. All right, so I'm ready to start this question. So when I look here, I first decide to look at my coefficients. I've got a 14 and a 21. And so thinking about my multiplication tables, I know that both 14 and 21 can be divided by 7. That's the largest number that both of those values, those coefficients, can be divided by. So I'm pulling out the 7. Now, next, I'm going to look at my variable term, my variable component of the term. So I have two factors of x here, and only one factor of x here. So in terms of what these have in common, the greatest number of x's that they have in common is 1. This guy only has 1x to donate, and this guy has 2. So I can't pull out 2 factors of x because the 21x only has 1 factor. So I'm going to pull out just that 1x. So that's what they have in common. Now I need to work out what's left over. So on the side or in my brain, I'm going to say, well, I said 14x squared. And I divided that by, I pulled out the 7x. So when I divide out the 14 and by 7, that leaves me with 2. And when I take x squared right here and divide it by x, using my exponent laws, I'm simply left with x. So I'm done with that. Now let's look at my second term. I've got the 21x, and I pulled out a factor of 7x. So I need to divide it out of the 21x and see what's left over. So 21 divided by 7 will give me 3. And x divided by x, well, those just simply cancel out. And so I'm left with 3, so then I say plus 3. If the value that I got was negative, I would be subtracting there. All right, so there I am. I'm done. I've common factored this. I can always go back and check my answer by multiplying it out. So 7 times 2 gives me 14, check. X times x gives me x squared, check. Let me use a different color here. 7 times 3 gives me 21. X times no x gives me x. So I'm back to where I started, and I've done a good job of it. Hopefully you did okay with that. Perhaps if you struggled, it might be helpful for you to talk to one of your classmates to help you make sense of it, or reserve your questions for when I am back in class. Yowza, you say. Well, here is our next example. And though it may look like it's a big step up from what we've been doing, it's really not. The process is the same. We've just got more pieces here. So I would like you to give this a whirl, and hopefully through doing the question, it'll convince you that I'm right about the fact that there really is not much difference in terms of how you go about common factoring a question like this. It just requires more steps. So go ahead and try to solve it on your whiteboard, and then when you're ready, resume the video and we'll take it up together. All right, so I'm going to take up this question. So first of all, I'm going to say, all right, I'm going to look at my coefficients here. So the first thing I'm going to do is I'm going to look at my numerical coefficients here. I've got 18, and I've got 36, and I've got 42. And so I'm looking for the greatest number that all of these three coefficients can be divided by. Now, I would say sometimes you have to start small and then work your way up. Whenever you have an even number, I know that even numbers can all be divided by 2. So then I'm just going to kind of do this work on the side here because it's just a good strategy. So I know 18 divided by 2 would give me 9. I know negative 36 divided by 2 would give me 18. And then 42 divided by 2 would give me 21. So now I really have to look at what I get. Was 2, in fact, the greatest number that all of them could be divided by? Well, I can see if I can keep going. Is there another number that 9, 18, and 21 can all be divided by? Well, hopefully you answered yes, because all of them can also be divided by 3, right? So I divided by 2, and then I know that all of them can be divided by 3 again. So 2 times 3 tells me actually what the largest factor is that all of them can be divided by. But maybe you need to start small and work your way up to figure that one out. So I'm going to pull out a 6. And so now let's look at our variables. Let's look at the a. So my first term has a to the power of 4, so 4 factors of a. Here I have 3 factors of a. And over here I have only 1 factor of a. So that means that the greatest number that they all have in common here is 1. This guy can't donate any more than 1 factor of a, and so I'm going to write that out. That's it. Now I'm going to look at my b's. There's another variable here. I have 3 powers of b, 2 powers of b, and 3 powers of b. So they all have at least 2 powers of b to be able to donate. So that means that I can put a b squared here. All right, now's the time for me to write out my leftovers. So I'm going to start my bracket. And so on the side, let me just get rid of some of this over here because it's kind of distracting. And I like to write big, so I would like to give myself a little bit of room to do this. And there we go. So over here, my 18, a to the power of 4, b cubed. I'm going to divide it by, and again, this is something you can do in your head once you get confident with it, or you can do it on, maybe a rough piece of paper. So 6ab squared, right? And so when I work that out, 18 divided by 6 leaves me with So now let's take a look at this next section here, where it says factor if possible. So we're moving on to the next level here. This question. So we're on to the next section here. This question, when I look at it, does not really resemble what we've been seeing so far. But we can factor it, and I've given you a bit of a clue here. It says, see the binomial, and where's the binomial? Well, it's this w plus 1 and w plus 1. We're going to see that as a single factor to be removed. Let me explain to you what I mean. Let's say, for example, this question instead, let's say I replaced the w plus 1 with a y. Then that whole question would look like this: 4xy plus 5y squared, wouldn't it? Because the y times the y, right? Well, you would know what to do with that. You would see that there's a y that they both have in common, and you would pull that out, right? And then write whatever the leftovers are. So the way of going about solving this question is pretty much the same as that. We're going to do exactly that. So I'm going to think about this w plus 1 as being a single factor that needs to be removed. So I'm going to do that. So since they both have that in common, I am going to pull it out as w plus 1, right? And so now I need to write out, well, what's left over after I pull that out? Well, if I pull out the w plus 1, the only thing that's left in this first term is 4x. And if I pull out w plus 1 in my second term, the only thing that's left is the positive 5y. So now I have factored this, and I'm done. That is it. Let's look at the next example. So here we have a similar case. I'm noticing when I look at this that there is a binomial that they have in common. And so as soon as I see that binomial that they have in common, I'm going to think about the strategy that I just used to solve the last question. Take a minute to go through this and solve it for yourself. And then we will take it up together. All right. So I see that there's that 2b minus 1 binomial that they both have in common, so I'm pulling it out as a common factor. And now I need to write, well, what's left over after I pull out the 2b minus 1? Well, from that first term, I have the 9a. And from that second term, I have the minus 3. So I can't just write positive 3. I have to write minus 3. And now I'm done. So I'm hoping you did okay with that. There'll be some practice for you to do. So be sure to remember that as you're looking through your homework, if you see that, that key binomial that's there in both terms, then you'll know to pull that out. All right, so for this next question, we're going to up the ante a little bit. This is the next level up. So you have the prerequisite skills to be able to do this. And I'm actually going to show you 2 different ways that you could solve this question. And both of them would be perfectly acceptable, and you'll see that. All right, so let's look at this. It says, whenever it says factor by grouping, okay, that's when you're going to follow this set of rules. So I've outlined it in some steps because I think that may help some of you to navigate it a little bit better. So the first step in my list says to group terms that have a common factor. So let's examine that. So in this case, I have AC, I have BC, I have AD, and I have BD. So I'm going to choose to group these 2 first ones together because, well, they have that C in common. So I'm going to just identify that I'm grouping them by putting little brackets around them. That's how I'm going to group. And I can do that as long as I see that in my other 2 remaining components, I have something in common, and I do. The D's are in common between those 2 terms, so I'm going to put little brackets there. So there, I've conquered step number 1. Next it says remove the common factor from each bracket. So at this point, I'm essentially going to just do what we did in step 1. So when I look at this first bracket here, I'm going to remove the C because they have that in common. So that's my next thing to do. So I'm going to remove the C out of my first bracket, and now I'm going to write out what's left over. Well, when I remove the C, I have an A left here and a B left here. So simply A plus B is left. Now I'm going to do the same thing to my second bracket. I see that there's a D in common here in both of the terms, so the D is what I'm pulling out. Now I write what's left over. Well, what is left over? I've got an A and a B. Surprise, surprise. So here I have A plus B. And I'm not sure how many of you have had an aha moment here. Maybe yes, maybe no. But you may notice that right here, there is an A plus B factor in each of the terms where I've pulled out the common factor. So notice that I've said in step 3, the binomials that remain should be identical. A good clue to see that you've done it properly is that, there should be 2 identical binomials in what results. So the next thing to do then is to do exactly what we did in example number 2, which is to remove the binomial as a common factor from each term. This term right here has an A plus B, and so does this one. So I'm going to pull it out. So A plus B. When I pull out the A plus B from the first term, I'm left with simply C. And when I pull out the A plus B from the second term right here, I'm left with D. So plus D. And I'm done. So now I want to show you an alternate way that I could have done that. And some of you may have thought, well, oopsies. Some of you may have thought, well, I could have grouped those differently. So I'm going to actually do that. I'm going to go ahead and I'm going to group them differently. So not sure if you noticed, but in both of those terms, I could have rearranged them. So for example, so you may have noticed I could have grouped those differently. For example, here I have an A and here I have an A. So in my second demonstration, what I'm going to do is I'm going to actually group those together. So AC plus AD. And then of course I can see that, BC and BD both have a factor of B. So I'm going to group those together. So BC plus BD. And so grouped and grouped. And I'm going to go through the exact same process as I did above. I'm going to pull out the common factor in each bracket. Here's an A, here's an A. So the A is getting pulled out. And what's left is, once I pull the A out, is the C and the D. And then I'm going to do the same thing in my second bracket. B and B, so common factor of B. Let's see what's left over. When I pull out the B, I'm left with a C and the D. So C plus D. And now I'm going to do my quick check. I need to check to see that both of my brackets, my binomials that result in the brackets are the same. They are. So I've done that properly. Now I can pull out the C plus D factor, because each of these terms, right, this is a term and this is a term, each of them has a C plus D. And so I'm going to pull out that C plus D as a common factor. And what's left over? Well, I have the A left over and then the positive B over here. So A plus B. And so let's compare our answers. So over here, I have C plus D times A plus B. In my first way of doing it, I had A plus B times C plus D. Well, the order here doesn't matter. It's kind of the same as saying, well, is 2 times 3 the same thing as 3 times 2? And we know that it is, which tells us that no matter how we would have chosen to group that, we would have ended up with the same mathematical answer at the end. So here is your homework assignment for this section on common factoring. Please save any questions that you have for me on Monday. This is super important as a skill for you to become really efficient at, and to also become really precise with getting the answers right. So give these questions a whirl. Give these questions a whirl. And if you're struggling with any of them, be sure to come and see me, and we will work it out.